Okay, next to the stage we've got Australian Vanadium, the Managing Director, Vincent Algar. For those that don't know Vincent, he's also a client and friend of our firm. He's a geologist by profession with over 27 years of experience in the mining industry, spanning underground and open cut operations, greenfields exploration, project development and mining services both in Western Australia and Southern Africa. Since 2015, Mr. Algar has been Managing Director of Australian Vanadium and is responsible for advancing the company's high-grade Australian Vanadium project in Western Australia. Mr. Algar was instrumental in the launch of AVL's subsidiary VSun Energy with its focus on developing the vanadium redox flow battery market for energy storage. Vincent has strong technical, ESG and financial knowledge and represents both AVL and VSun Energy to the mining, financial and energy markets within Australia. Welcome to the stage, Vincent.
Thank you. Good morning. My name is Vincent Algar, as indicated. It still is. I'm the Managing Director of Australian Vanadium Limited. Our company has been listed on the Australian Stock Exchange since 2007, and I've been with the company for over 7 years now. In that time, we have progressed the Australian Vanadium project from an inferred resource to having completed a bankable feasibility study. The company is well funded until its final investment decision, with share price performance over the last 12 months having been strong. Interest in AVL has been driven by our advancement of the project, also by increasing knowledge of the benefits of vanadium as a green steel metal, and also the massive potential of vanadium as part of the growing energy storage market. The project is currently one of the world's highest grade undeveloped vanadium projects. The bankable feasibility study just demonstrates attractive economics, and the company has cash available to complete its work required until final funding. We are actively engaging with EPC and EPCM contractors for the engineering completion. The project is regarded as a critical minerals project, with major project and lead agency status awarded by the federal and state bodies respectively. The company was recently awarded a $49 million grant under competitive conditions by the Australian Government's Modern Manufacturing Collaboration Initiative for Critical Minerals. The key focus for the company at this time is securing finance and offtake of our product, possible now with the recent level of study completion. Through its 100% owned subsidiary VSun Energy, the company is actively growing downstream opportunities in the battery space inside Australia through the supply of vanadium redox flow batteries. Vanadium is primarily used in the steel industry, with 92% of its global consumption being used in steel rebar, shipping, tool and rail high-strength, low-alloy steels. Chemicals and specialized titanium alloys are of very high and strategic value, leading to the designation of vanadium as a critical mineral. The emerging market of great interest is in energy storage applications when used in the all-vanadium redox flow battery, or in the anticipated future use of vanadium in cathode and anodes of lithium-ion batteries. AVL sees strong growth and opportunities for premium price offtake in this sector in the coming years, leading to shifts in demand and pricing structures within the entire vanadium market. Similar to other small critical mineral markets, vanadium is dominated by China, which produces and consumes over 60% of the world's vanadium. Russia produces another 10%, much of which previously found its way into North American and European markets. Production in China and Russia is generally by slag steel methods from titanium, vanadium, magnetite ores. Only 3 primary mines outside China are currently operating. These are in Brazil and South Africa, also mining vanadium titanium magnetites. New steel markets in India and Southeast Asia and the geopolitical shift away from China, supply chain dominance implies that now is the time for new mines to be developed. In this diagram, we talk about the future growth of vanadium, which is in the blue bars, and we see steel consumption as it slowly increases using more vanadium in that steel. But the red bars show the potential growth for the vanadium redox flow battery sector in stationary energy storage. You can see that this growth reaches a significant proportion of overall demand in the very near future, sufficient to start to shift pricing and market structure. So what is all this noise about the vanadium redox flow battery? It's an Australian invention, so that's an important starting point. A lot of the excitement is about the VRFB being a true load-shifting storage system. It's a scalable energy battery, similar to pumped hydro schemes, but much more flexible in terms of its location, size, and cost. These are long-life network or microgrid assets and do not degrade in performance over time, and are part of a circular economy in that all the vanadium in the battery at the start can be extracted and reused at the end of life. Importantly, they are inherently safe, with flammability being negligible compared to the known issues with lithium-ion batteries. Together, the features of VRFB offer a lot of reasons for it to be a participant in the energy transition where electrification and removal of carbon fuels is essential. As mentioned by the previous speaker, people are the essence of project success. And AVL has begun its journey by composing an experienced corporate and technical team, boasting very, very strong international vanadium credentials. Daniel Harris and Todd Richardson in our team have spent their entire careers in the vanadium space and have worked across the whole world of vanadium in operations and sales. This gives us a very strong basis, given the very limited number of vanadium projects in the world in operation. We continue to grow an experienced technical and strong team to deliver the project. We do favour working with industry leaders as external partners. With regard to ESG, at AVL we believe in ESG in action. As a small company, we have to take actions on things we can do the most on at this stage of the project development. And we look to do things that will make a difference on each of these elements. Active already, we strive to improve by design and take action immediately where possible. Let's consider carbon dioxide emissions reductions and downstream impact for the moment. In the chart, we see a comparison of our carbon emissions expected from the project compared to similar other projects. AVL will likely use around 16 tonnes of carbon dioxide per tonne of vanadium product at the start of production. And by using hydrogen and renewable energy and energy storage, we plan to reduce the Scope 1 emission over time. Very excitingly, recent research has shown that the use of vanadium in 400 megapascal high-strength low-alloy steel can effectively reduce carbon dioxide consumption by up to 1,250 tonnes of carbon dioxide per tonne of vanadium deployed. This is a massive impact for a very small input, and it results primarily from the reduced amount of steel used and the reduced amount of concrete needed in the resulting buildings. In terms of community involvement, we're working on action now again. Involvement in regional communities via kids and adult sports sponsorship, CRC and Chamber of Commerce involvement, and local staff employment in Geraldton. We have a strong and competent board of directors adhering to ASX principles and long-term commitment to policies in keeping with the evolving governance environment. We have in place a clear renewable energy vision, focusing on affecting the energy transition and decarbonisation, striving to meet net zero by 2050 goals. These are embedded in our outward-facing environmental impact plans and our greenhouse gas management plans. The project itself is located 40 kilometres south of the town of Meekatharra, about 450 kilometres from the port city of Geraldton. The company has evaluated the benefits and specifically chosen to separate the mine and the ore concentrator from the product processing plant. This is a strategic distinction that gives the company a unique opportunity presented only here in Western Australia at this location. It allows processing that utilises the close proximity of the Dampier gas pipeline, the port, and the population of the city of Geraldton. Transport routes open up a unique opportunity not available to any other vanadium producer in the world, which is to sell a titanium iron by co-product, offering a hedge and a potential additional revenue stream. The Midwest region also offers access to abundant renewable energy resources, including hydrogen production. The concept of a processing hub applies to our plant, opening up the opportunity to process other feedstocks beyond the initial 25-year project life from overseas and local sources. A recent bankable feasibility study completed by the company in April 2022 indicates robust project metrics, producing around 5% of the world's vanadium needs. Mining will tap into an ore reserve of around 30 million tonnes, part of a much larger 95 million tonne high-grade resource using standard open pit methods. The focus for the company has always been to maximise vanadium recovery while maintaining a globally competitive operating cost. This has been achieved in the feasibility studies despite rising overall costs for mining projects. While the project has a relatively high capital cost, the company is using this period to identify opportunities to reduce CapEx and OpEx, as well as increase revenue in the lead up to final financing, development, and production. Just a quick look at the project geology. It extends over about 8 kilometres, is made up of a kilometre scale ore blocks, resource blocks, each of which is slightly varying physical characteristics, but with very consistent geological sequence in the Lady Elmo intrusion. The economic target horizon, shown in pink at the base of the section on the right, is about an average 14 metres thick across the entire project. And because it's a massive magnetite, it provides excellent mass yields throughout the entire circuit. Detailed design and planning of the beneficiation and processing plant is complete, undergoing minor refinements as we head towards final investment decision. You can see from the videos, which I hope are playing, that there's a high level of technical detail in the designs, but you can also see the simplicity of the smaller environmental footprint imparted by having the plants separated. Processing is achieved by crushing, milling, and beneficiation, magnetic separation to produce a concentrate. This is trucked to the processing plant where the concentrate is pelletized, roasted in air, leached in water to extract the vanadium. The co-product iron titanium is then prepared for shipment, while the vanadium is extracted from the leach solution to produce vanadium pentoxide. So where to now? The company sees itself as a vertically integrated vanadium producer, mining and processing vanadium products from the high-end steel, chemical, alloy, and battery industries. Unlike the lithium-ion precursor materials, vanadium electrolyte production is a much simpler step when high-purity products are available. Involvement in VRFB sales, assembly, and installation are already an active part of our downstream model through our VSUN Energy subsidiary. Our project delivery plan is currently underway. With the BFS completed, we are now moving towards a final investment decision later in the year. We are busy selecting EPC and EPCM partners with each of the plants, as well as mining, transportation, and shipping partnerships. When we reach financial close, we will execute front-end engineering design, head towards construction late in 2023, and planning first production in 2024, completing our journey to become the world's next primary vanadium producer. Approvals are well advanced in both sites and are not on the critical path. Just in summary, the company has the vanadium expertise and is well placed in terms of market timing for the delivery of new vanadium into the steel and battery markets. The project is globally significant and has strong business fundamentals at a time of geopolitical and critical material supply chain uncertainty. With a long project life to look forward to and our focus on more than mining, a vertically integrated approach, and the involvement of renewable energy, the company can take action on energy transition goals while delivering an attractive return to shareholders. Thank you for your time today, and please come and visit us at our booth, at booth number 13, over the coming days.
Thanks, Ian. We've got a couple of minutes for questions if you'd just like to raise your hand.
No vanadium lovers out there?
Well, just from my end, Vincent, obviously the conversation around ESG is more and more prevalent amongst the larger cap names and also the smaller emerging companies. Someone that's been in the industry for a long time now, how much of your board's time and effort and thinking is being, I guess, motivated and directed by that focus? And is that continuing to increase? Are there more board ads or advisors that you need to see to help you get through what's not always the clearest path?
No, I think it's, as a growing company, I think growing that capability is essential at the moment. Quite difficult to focus on it in the early stages like this, but it has become very, very important to focus on. I think being in an energy transition metal like vanadium, where it has opportunities to bring that to the story on the decarbonisation, has helped us a lot. But I think we've also reached out to experienced consultants and other parties to start to educate us right across the group, right from the board level and all the way down. I think that education is the key part of our growth strategy.
Great, thank you.
One more question.
Question from John.
Hi, Vince. Thanks for the presentation. A question in keeping with the previous years in two parts. The first part is, what time frame do you think we're going to see a greater adoption of flow batteries into grids? Obviously, lithium and more portable solutions are taking off, but the growth of vanadium could be exponential if we see that, but I'm interested in the time frame. And the second one, unsurprisingly, Dorothy Dix, is how important is logistics in the Midwest as a potential miner?
Well, logistics are very important.
This answer's coming out of John's time slot, by the way. So.
I'm glad to hear it. Yeah, logistics are a key part. I'll ask that price first, John, it's easy. Logistics are a key part of the solution. Knowledge and of that area, being able to find a solution into the port, having the Port of Geraldton respond to needs of operators in that region is very important as well. And obviously having the goodwill of the corridor that we have to operate in. It is unusual that we've separated the two plant and the processing plant from the mine, but we do believe, as I mentioned earlier, that's a key part of the actual solution itself, in enabling a longer life for the project itself. Getting back to your earlier question, which I've now forgotten.
The flow battery.
Oh, the flow batteries. How could I forget?
5 years, 10, 20?
No, I think there's a bias at the moment with lithium ion, and that's a fair bias because their cost of production is low. So the flow battery companies that are out there, the OEMs that are building these batteries, have to be more engaged with the vanadium producers, and we've been attempting to do that through our organisation, Vanatec, for the last 5 years or so, and that's slowly coming to fruition. There is a lack of investment in those OEMs to bring their manufacturing costs down and increase their capability, and the vanadium itself will follow when those objects are there. So I think we're in the 2 to 3 range, maybe the 3 to 5 range, but those predictions are coming from multiple sources, and we're very excited by the possibility.
Thank you.
Thanks, Vincent. All right, let's keep moving. Thanks again. Next up, we've got...